which trig function should I use? From chapter 7. Okay, this says to find the lengths, find the value of x to the nearest tenth. Okay, so we have a 41-degree angle here. And so we notice that x is the adjacent side to the 41-degree angle. And this would be the hypotenuse, but we don't need to worry about that yet. And number 12, or the side with the 12, is the opposite side. So we have the opposite and adjacent sides. So looking at TOA, we say the one that has the opposite in the, whoops, not that one. The one that has the opposite in the adjacent side is the tangent. So we are going to use tangent 41 equals opposite, which is 12, over adjacent, which is x. Now I need to see this equation. And some of you from there will have memorized what you need to do. You'll know that to find x, you have to divide 12 by tangent 41. Some of you aren't going to bother to memorize that. That would be me. I don't bother to memorize that stuff. And the way you do this algebraically is you multiply both sides of the equation by x to get x out of the denominator. That makes it cancel over here. Now you have the x over here. You want to divide by tangent 41 on both sides to get the x by itself, and you get x equals 12 divided by tangent 41. Now let's look at how to key that in to the calculator. Okay. If you have a Texas Instruments calculator, it will look like this. 41 divided by tangent, excuse me, not 41, 12 divided by tangent 41. And you get 13.8. If you have a Casio type calculator, it will look like this. 12 divided by, and you put in the 41 first, then press the tangent button. That's the tangent of 41. So you have to press equals to get it to do the division, and you get 13.8. So we have 13.8. And we found x. Okay, for this one, we're looking at our 27-degree angle. This is our opposite side, and this is our adjacent side, so we're using tangent again. And we're going to say tangent of 27 is equal to the opposite side, which is x, over the adjacent side, which is 15. We'll multiply both sides by 15, and we get, using the Texas Instruments, we will say 15 times tangent 27 equals 7.64, which is just going to be 7.6. Or, using the Casio, we're going to say 15 times 27 tangent. That's just the tangent of 27, so we press equals and we get 7.64, which is just 7.6. 7.6. Okay, let's get some different kinds of problems here. This says use a sine or cosine ratio to find the value of each variable. Round decimals to the nearest tenth. Well, I'm actually going to use either cosine, sine, or tangent because I want you to learn to use any of them. So here we have a 57-degree angle, and the opposite side is the one we have a number for, which is 14. Now I want to remind you that you can find the other angle by saying 90 minus 57, which is 33. So you can use either of these angles using a sine, cosine, or tangent ratio. I would like to have my variable on the top rather than on the bottom because I don't like doing that division. So I'm going to try using the 33-degree angle here. If I use the 57, I would be looking at opposite over hypotenuse or adjacent over hypotenuse. We can't do adjacent over hypotenuse because it's not a number. And so I just really don't want to have to move that variable out of the denominator. So I'm going to use 33, and I'm going to say 14 is my adjacent side, and whoops, I want to do opposite over adjacent. So I'm going to use tangent instead of sine or cosine in this case. I could use cosine because 14 is the adjacent side over the hypotenuse, and I could find b that way. But I'm going to use a tangent ratio here. So you can use whichever one you can find the parts for. So we have 33 degrees equals a over tangent of 33 degrees equals a over 14. I'm going to multiply both sides by 14. I'm going to repeat this equation. I have to see. If the rest of it you just do on your calculator, I'm okay with that. Okay, and I'm just going to use one calculator. I'm going to use the one that fits in the space we have here. Okay, so this is 14 times 33 tangent equals 9.09, but we're to round to the nearest tenth, so that makes that 9.1. So A is equal to 9.1. Now when I go to find B, I have no choice about putting that B in the denominator because B is the hypotenuse. And in SOHCAHTOA, the hypotenuse is always in the denominator. Now remember, I told you as often as you can use an original number rather than one you calculated, you should do that. You'll get a more accurate answer. And since 14 was my original number, I'm going to use 14. And this time I'm going to use my 57-degree angle. I could use either one. Okay, if I use my 57-degree angle, so is the one that I need because 14 is the opposite side. So I'm going to say sine 57 degrees is equal to the opposite side, which is 14, over the hypotenuse. Again, I'm using this 14 because it was an original number I was given. I didn't have to round it to get it. It was given to me. Okay, I've got to get the b out of the denominator, and then I have to divide by sine 57. Once again, the part that I need to see is the original equation, and I've got 14 divided by sine 57. In order to see the calculator, I have to move the iPad out of the way. 14 divided by 57 sine equals 16.69, which rounds to 16.7. So B is 16.7. 16.7, and I have found both variables. Okay, let's move over and do another one. Okay, I have a 41-degree angle here. That makes this one 49. This 49 and 41 is 90 degrees. And I have a hypotenuse that I'm looking for. And I also can look for either the opposite side or the adjacent side, depending on how I'm looking at it. I want to, let's write our reminder up here. SOHCAHTOA. Okay, I want to use I want to have the variable in the numerator. So I'm going to use cosine 41. Now I know I said use the things that you're given originally, and 49 is not given originally, but it is exact because 90 minus 41 is 49. But I'm going to use cosine 41 because cosine is adjacent over hypotenuse. And that puts my I can't do that. I hate it when I make a mistake when I'm making these videos. So I'm not going to use cosine. I'm going to have to start with a tangent. Or I can use a sine. Okay, let's do sine 41 equals 17 over d, and I'm going to move the d up into the numerator, and I'm going to divide both sides by sine 41. I'm using my calculator. Divided by 41 sine is 25.9. So D is 25.9. Now if I'm going to follow the directions, which was to use sine and cosine, I'm going to be using the D that I just calculated to get my new answer. So I'm going to use cosine because cosine is adjacent over hypotenuse. Oops. Cosine 41 degrees equals adjacent C over hypotenuse, 25.9. Multiplying both sides by 25.9, I get C equals 25.9 times 41 cosine equals 19.546. Do not use the 6 to make the 4 a 5 and then the 5 to make the 5 a 6. Okay, just look at the 19.5, look at the next digit, which is 4. That's below your halfway point, so it's 19.5. And C equals 19.5. Ah, this is a nice one to do. Okay, this time we have the hypotenuse, which is kind of nice because we can look at this and say this is 47 degrees, so this must be 43 degrees. And we can say if I want to find the x, I can use, that's the adjacent side, and we have the hypotenuse. So adjacent and hypotenuse goes with cosine. So I say cosine 47 equals adjacent, which is x, over hypotenuse. Multiply both sides by 12. Using the calculator, 12 times 47 cosine equals 8.18. When we round that, it will become 8.2. So x is 8.2. And then I'm going to use sine 47 because I want to find the opposite. Okay, so opposite over hypotenuse goes with so. Sine 47 equals y over 12. Multiply both sides by 12, and I get 12 times 47 sine equals 8.77, which is 8.8.